Hello guys, welcome back. In this video, let us learn about one more interesting topic in AWS and AWS services that we use to achieve that topic. In this video, we'll learn about decoupling architecture. Before this, what we use and why do we prefer to go for decoupling architecture? So that's also we'll learn. So before using decoupling architecture, we are using one architecture that is monolithic architecture. So after using this monolithic architecture, in order to overcome the problems which we are getting when using this monolithic architecture, we shifted to decoupling architecture. So now let us see what is this monolithic architecture and how our applications are on this monolithic architecture. In monolithic architecture, let's see how a project is hosted. So what is a project, sir? A project is nothing but combination of multiple applications, right? Yeah. So a project can able to perform multiple applications functionality. So now let's say I have a project with multiple applications. So one application runs on one server. One application requires some dependencies and another application requires some dependencies like that. I have multiple applications which are present on a project. Let's say my project is a big project. In that case, I have more than two applications also present inside my project. In monolithic architecture, what we did is we host our whole project. We host our whole project on single server, or you can say we host our project in single server or in a single EC2 instance. In AWS, we call servers as we use EC2 instances as servers, right? Yeah. So if we consider the AWS service, then hosting whole project in a single server happens in this monolithic architecture. Now, this application requires some dependencies and this application requires some dependencies. So in order to run this application on top of this server, do I need to download all the dependencies required for this application? Yes. We need to download all the dependencies required by this application on top of this server. Now, in order to run this application on top of this server, do I need to download all the dependencies that are required by this application as well? Yes. We need to download all the dependencies required by my all applications. So this might happens in real time that some software do not support other software. In real time, when you are using two applications on a same server, or else if you take an example of your laptop, then if you try to install two softwares at a time, then what happens is sometimes they may stop in between because some dependencies, some software dependencies which are supporting by one application or one software may not support the other software. So in that scenario, we are unable to use another app, right? Yes. Why? Because if we download one application, then those software dependencies will be interlinked to application one, as well as those software dependencies also linked to application two. That means the both applications are tightly coupled in monolithic architecture. Now, let's write down the points as well. It might happen that one application dependencies may not support other application dependencies to be installed on the server, right? So even that causes an issue of failover of your another application, right? Yes. So let's say you have your application dependencies are supportable. That means you are allowed to install all the dependencies that are required by app 1 and app 2. You would not have encountered any problem here, let's say. Now, the application dependencies which you install on your server, those dependencies can be used by both application 1 and application 2, right? Yes. So can I say they both are tightly coupled by the dependencies, right? Yes. So the both applications are tightly coupled. Let's say in my project, if one of my application fails, if one of my application got failed, then can I say my whole project working will be disturbed? Yes. My whole project working will be disturbed. And let's say my application 2 is failed and the dependency is also not working. And my application 1 also using some dependencies that application 2 is using. Can I say application 2 using dependencies also not working? Yes, because the both applications are having same dependencies. In that scenario, what happens is if due to one application the dependencies are not working, then other application also does not perform its task perfectly, that is correctly, because their dependence is also not working, right? Yes. So that's why one application failure may also cause other applications failure as well. So this is also one of the issue, right? Yes. So due to this applications tightly coupled, we have one more issue, that is if one application fails, then it may also cause other application to be failed in your project. So can I say my whole project got damaged? Yes. Now, what's the task is to overcome these two issues, these two main issues. There are several issues, but these two are the main issues when using with monolithic architecture. In this, what happens is your applications are tightly coupled and dependent with each other and dependent with each other. They're dependent with each other. Applications are. So due to application dependencies, if one application fails, another application also fails. And one application dependencies may also not support other application dependencies. So that application dependencies which are first installed, they may avoid installation of other application dependencies, or they may delete the other application dependencies in order to install that particular application dependencies. Now, in order to overcome this issue, we come up with a solution, that is what? Decoupling architecture. What is that? Decoupling architecture. In this, what happened? How these two issues will be overcome? So in this, it overcomes these two issues by simply loosely coupling. That is by using decoupling architecture. By using decoupling architecture, your applications are hosted on different servers. Your single project applications are hosted on different servers. Since one application hosted in one server and another application hosted in another server of your project, it can able to overcome the issues, both issues. That is, one application dependencies not affect may not affect other application dependencies, because this application dependencies will install on this server and this application dependencies will install on this server. So whatever the dependencies which are present in the server will not affect the dependencies present in the server, because they both are different servers, right? Yes. So they both run on their way. And second issue, that is one application failure does not cause another application failure also. Here you can see if one application fails, then it will affect only under the server dependencies only. Since there is no dependency of this server and its dependencies, this application is still working. So this application 2 functionality is still working whenever application 1 functionality is not working. Then let's say if they want communication between them, if they want communication or interaction interaction between these applications, then we can able to use decoupling services. In AWS, do we have any such services, sir? Yes, we have. We can take an example of SQS. By using this SQS, we can able to implement this decoupling architecture between multiple applications which are hosted on different servers or different components. Or if we talk with respect to AWS, then if we host our applications on different services like on EC2 or on Lambda, or so like that, we can able to provide interaction between those software as services by using this simple queue service. We can able to provide those interaction between those microservices by using this SQS service. In monolithic, if we compare the major difference between these two architectures, in monolithic architecture, your applications or services or components which are dependent to each other, and they operate and execute by depending on other applications. Whereas here, the execution and operation of one application will be independent to other application, because the applications or services or components which are independent to each other, right? Yes. So that's the major difference between these two architectures, that is a monolithic and decoupling architecture. For implementing a constant interaction between these two services, these two applications or components in decoupling architecture, we use a constant interface. So whenever one application fails also, whenever a application fails also, the other application is still working. So other service is still working. So user can able to accept the functionality of other system, other services. Even if you use this decoupling architecture, your whole project do not fail. If an application fails also, your whole project will work except this application's functionality, except the service. Other applications and their servers services will work. This whole project won't damage. We can only develop this independent application by interacting with it. So each and every applications will communicate by using a specific constant interface in this decoupling architecture. This is how they overcome these two problems by choosing this decoupling architecture. So this is why we use decoupling architecture nowadays for real-time projects implementation. So I hope you understood why we moved from monolithic architecture to decoupling architecture. That is from single server to multiple microservices. For a single project, using single server to multiple microservices, why we moved. So I hope you got a knowledge why we moved and how do we overcome the issues when we use monolithic architecture. So those all things I hope you learned from this video. I hope you understood about decoupling architecture from this video. If you feel this video is contentful and you got some knowledge or knowledge recap from this video, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye guys.